All right, for this third video on significant figures, we need to talk about how we use them in calculations, which is kind of the point of getting that we're trying to get to, is what are the rules for using them in calculations? This is a little trickier than it seems because what people tend to remember is the rule for multiplying and dividing. However, there's a different rule for adding and subtracting. And where it really gets tricky is when we have a problem that incorporates multiplying and dividing along with adding and subtracting. And we have a lot of those in chemistry. We add up numbers off the periodic table to get a molar mass, and then we stick that into a problem where we multiply and divide. And so that's just one instance of where we would add up numbers and then multiply and divide with them. And so we have to apply both these rules to the part of the problem that they belong to. So knowing both rules is important. So let's do a little sample problem for each one of these rules, just so that we make sure that we understand them. Let's start with a problem where we would multiply and divide, because we probably do that a little more often. So let's start with a fun problem where we would take some mercury. Mercury is a liquid, a silver shiny liquid that is fun to play with, but it's not recommended to play with it because it's also toxic, sadly. So we are going to take our mercury and we're going to figure out if I have 6 and a quarter-ish grams of it, how many milliliters would that be? Now mercury is really heavy stuff, so 13.5 grams in a milliliter, that's really heavy, that's very dense. And so I can use this density and put it in a conversion factor and come up with an answer for a number of milliliters. I would have to turn it upside down so that the grams end up on the bottom, right? And milliliters end up on top. So I'm going to put my 13.5 here, 1 milliliter there, and now I'm going to look down at my calculator and write down what the calculator told me was the answer. Calculators, unlike you, are stupid little beasts. They do not understand Sig Figs at all. Again, unlike you. And so this is what the calculator told me. It's at 0.463259259 milliliters. We did not measure the mercury nearly that carefully, right? We know that we have 6.254 grams. That's pretty carefully measured. We know it to a milligram. So we have 4 Sig Figs here. 4 Sig Figs, right? We know the density of mercury to 3 Sig Figs. That's also measured. Somebody measured that and figured that out at some point. And so we have 4 Sig Figs and we have 3 Sig Figs. Multiplying and dividing, that rule says whichever one is less precisely measured, we're stuck with that precision. We don't have any more precision than that, and so we can only have as much precision as our lowest precisely measured component of our calculation. So 1, 2, 3, that's how precisely we are measured 1, 2, 3. So we're going to have to cut it off at that point. By cut it off, I mean round it, right? So we're only going to get 1, 2, 3 Sig Figs. If this 2 were an 8 or a 7, I would round up. But as it is, since it's a 2, I'm just going to drop it away. And so we're going to say, instead of this whole long schmear of calculator nonsense, we're going to write 0.463 milliliters. And that's going to be our answer, because that's how precisely components were measured. Okay? Now we need to talk about what we're going to do with adding and subtracting. That was a great rule. That's multiplying and dividing. It doesn't apply to adding and subtracting. So let's get an adding and subtracting example going here. Maybe I'll come over here and do that one. Okay, adding and subtracting. So now let's say I have 1.2 grams. This is going to be grams, all right? I have 3, let's say 32.61 grams, and I have 31.189 grams. and I add all of these up, okay? Look at that. So let's add these up. How many grams do I get? So I'm going to add 9, and I'm going to add, that's a 9, and 6, 7, 8, 9. Oh, that's another 9. How about that? I just made these numbers up, and it just turned out to be a lot of 9s. 6. So there we are. So we measured this, we measured this, we measured this, we added them all up. That's how much we should have total. How do we know what to do about this place right here, and this place right here, and this place right here? Well, you know, because your elementary school teacher, I don't remember when they taught you how to add decimals, right? But somebody said when you have a hole here, right, when you have these little empty spots, just pretend like it's a 0. In fact, maybe some teacher along the way told you to put zeros in there and treat it like zeros. It's not zeros. We don't know what was there. If you'd had a better balance here, instead of a balance that only went to 1/10 of a gram, this might have been 1.21 grams. It might have been 1.22 grams. We don't know. So by putting a 9 down here, we're really kind of lying, pretending we know what it is. We don't know what it is. So we can't put a number down here since we don't know what that was if we measured it with a more precise instrument. So we are stuck cutting off our number at the point where we have no information, whatever decimal place that is. So since there's no information here, there's no information here, there's no information here, we have to just, at that first empty spot, that's where we end. Now, do we just cut it off? No, we have to round. So we look at this and I say 64.9. If I just cut it off, okay, no, I can't. I've got to round it because this 9 would make it round. So I would say 65.0 because the 9 would make it round up. So 65.0 grams is my answer. Now, did I do that by looking at the most or the fewest? I had 2 Sig Figs here. I had 4 Sig Figs here. I had 5 Sig Figs here. And I ended up with an answer of 3 Sig Figs. You can see none of these had 3 Sig Figs, but I ended up with 3 Sig Figs in my answer. So we're absolutely not using the same rule as multiplying and dividing. It's important when you're adding and subtracting to use this rule. When you're multiplying and dividing, use this rule. You can't use the rules for the wrong purpose. Sig Figs, lots of fun. Okay.